This is Module 10, Section 5.7. In this section, we're going to talk about division of polynomials, but we're only going to look at one specific case. We're going to look at polynomials divided by binomials. I'm sorry, polynomials divided by monomials only. Dividing polynomials by monomials. From elementary school, we know that a divided by b plus c divided by b is equal to a plus c divided by b. Now, I'm going to write that out in a little better fraction form. A over b plus c over b is the same as, when you're adding fractions, combining that fraction into a single fraction over that common denominator and adding your numerators. And using numbers, just to make sure you agree with me, if you're taking, let's say, for example, 1/3 plus 4/3, you agree with me that to do that math, if it's a common denominator and you're adding, you simply add your numerator, and then in this case, since these are numbers, you can take it a step further and get in improper fraction form 5/3. Okay? Therefore, the reverse is also true. If you started at this point and worked in reverse, it also should be true that 1 plus 4 divided by 3 should be equal to 1/3 plus 4/3. Has to be if the two sides are equal. Okay? Now what you did there, if you think about it, is you took one big fraction that had a single term denominator and you split that denominator out to each term in the numerator individually. That gave you this, and you got an equivalent expression. We are going to use this to simplify polynomials divided by monomials. Okay, so our first example is we're going to divide 14x squared minus 9x to the 5th divided by x. Now the way to recognize these is, notice that we have a polynomial up top, which means we have addition or subtraction in our numerator. And we have a single term, or a monomial, in our denominator. There is no addition or subtraction in our denominator. So we're going to use that simple fraction policy that we just talked about. If you have a single term there, you should be able to separate that out into two separate fractions and get an equivalent expression. So we've got 14x squared divided by x minus 9x to the 5th divided by x. The reason that that's an advantage is because now we can simplify each of those individual fractions because we no longer have addition or subtraction in them, so we can just use properties of exponents. Here we've got 14, and then these are like bases, so we can subtract the exponents, 2 minus 1. Minus 9, same thing here. We've got like bases, so we can subtract the exponents, 5 minus an understood 1. And that gives us 14x to the 1st minus 9x to the 4th. Now that's subtraction, and those are unlike terms, so you can't combine them. That would be your final simplified answer. All right, let's do this problem. Let's do 8x cubed minus 4x squared plus 6x plus 2, and let's divide all of that by 2. Polynomial up top, single term or monomial in the basement, so we're going to split that 2 out to each of those terms individually and make 4 separate fractions. So that's going to give us 8x cubed divided by 2 minus 4x squared divided by 2 plus 6x divided by 2 plus 2 divided by 2. And simplify each of those individual fractions if possible. Okay, here, 8 divided by 2 leaves you with 4x cubed. Minus 4 divided by 2 is 2x squared. plus 6 divided by 2 is 3x, plus 2 divided by 2 is 1. Those are all unlike terms, and since you're adding and subtracting without like terms, you can't combine them. That is your final answer. All right, let's do another example. Let's look at 6a squared minus 4a plus 12, all divided by negative 2a squared. Single term in the denominator. So we can take that and we can split it out individually. So that will give us 3 separate fractions. We've got 6a squared divided by negative 2a squared minus 4a divided by negative 2a squared plus 12 divided by negative 2a squared. Clean that up where possible. Okay. On our first group here, 6 divided by negative 2, that's even division. 6 divided by negative 2 is negative 3. And then a squared divided by a squared divided by a squared is going to cancel out. Anything divided by itself is 1, or if you want to, you can use property of exponents. This would give you a to the 2 minus 2 power, which is a to the 0. Anything to the 0 is 1, and negative 3 times 1 is just negative 3. Okay? Now here, notice you've got minus a negative. Minus the negative is the same as adding a positive, so this is going to end up being plus. 4 divided by 2 is 2, and you've got like bases here, so subtract your exponents, a to the 1 minus 2 power there, plus 12 divided by negative 2 is negative 6, and then that a squared is still down in the denominator. You don't have anything to combine it with. If it's in the denominator to begin with, it has to stay in the denominator. All right, now let's work with that a little bit. We've got negative 3 plus 2a to the minus 1 plus negative 6 over a squared. Here you know that you can't leave a negative exponent in your final answer, so you're going to have to pull it down. And your final answer will be negative 3 plus 2 over a to the positive 1 minus 6 over a squared if we change that plus negative to subtraction. And there's your answer. All right, let's do one more example. Let's do negative 12x cubed plus 36x minus 15, all divided by 3x. All right, split that into 3 individual fractions, and you've got negative 12x cubed over 3x plus 36x over 3x minus 15 over 3x. All right. Here, negative 12 divided by 3 is negative 4. And we've got like bases here, so we can subtract our exponents, 3 minus 1, plus 36 divided by 3 is 12, and x divided by x cancels out. Anything divided by itself is 1, minus 15 divided by 3 is 5, and that's divided by x, which is down in the denominator, and nothing you can do with that. Clean that up. You've got negative 4x squared plus 12 minus 5 over x as your final answer. And this is the end of Module 10, Section 5.7 material. This is also the last video for Module 10. You should now complete the homework for Section 5.7 found in my math lab. When you have successfully completed the above homework, review all of the material for Module 10 and complete the Module 10 exam found in my math lab. After successfully completing the Module 10 exam, you may proceed to the Module 11 videos.